Right, hello everyone. So, what we're going to have a look at today is financial maths. And we're going to start in with compound interest, which is kind of the basics for a lot of financial maths. So, I'm going to show you the formula. And again, you can find these in the log tables, thanks to God. So, we have f is equal to p bracket 1 plus I to the power of t. Now, this can vary in books, it can vary, but I think this is the one that's in the formula in the log tables, so it's important to know this one. So what does the F stand for? That's going to stand for the final amount of your investment or whatever. This is going to be your starting or initial amount. And it used to be called, in my day, we used to call this the principal. Okay, it might still be called that in business or accountancy or something like that. And then we have a bracket, so there's a multiplication operation there, but the bracket gets done first. Okay, so what we have here is 1 plus I. Now the I is the interest in decimal or in fraction form. Okay, and then T is the period. So usually years, but could be months. Okay, so that's when we look at these first couple of examples, what we're going to be looking at is manipulating this around. Sometimes we want F, sometimes we want P, sometimes we want I, and on a rare occasion we want T. So that's how it's kind of set up. You would be familiar with this from third year honors, but again, it's one of those things that there's no harm in looking at it again. So we're going to dive in and try a question and just see how it works. I'll keep referring back to this. I just fold it over so we can have it there to show, as the man says. So just get that. So when I do that, you can have a look at that question there. See, does anything identify itself? So, right. Sean invested 4,500 for 5 years in Eurobank. His investment amounted to 560782 at the end of his term. Find the AER. So first of all, let's figure out what AER, annual equivalent rate. Okay, so that's usually a rate in investments. Okay, so we want to figure out the I value basically that generated this amount from that amount. Okay, so we want I. So listen, like anything else, let's put in what we know. Okay, so we have a principal, we have a starting point, we have 4.5, we have a final amount, we have 5607.82, and we have a time, we have 5 years. So we have a t equals 5. So let's put our formula together. F is equal to p bracket 1 plus I to the power of 5. Okay, so that's what we're going to do. We're going to put our numbers in. We're going to put in 5607.82 is equal to 4,500 bracket 1 plus I to the power of 5. So this is just a case of manipulation. So get out your friend, Mr. Calculator, and he's going to do the manipulating for us. So divide both sides by 4.5. That'll cancel that there, and you'd have 5607.82 divided by 4,500. So that's going to be equal to 1 and I to the power of 5. And then what are we going to do next? Well, listen, if I want to get rid of the fifth power, then I just get the fifth root on this side. So that's going to be 1 plus I equal to the fifth root of this 5607.82. Okay, and then if I want I, well, then I just subtract 1 from both sides. So I is going to be equal to this, which is the fifth root of 5607.82 divided by 4,500 minus 1. Okay, so I'll do that now all in one go. You see, I didn't bother using my calculator until I got to this point, until I manipulated it as far as possible. Then I go to the calculator. I don't do it as I go along, because what happens is mistakes can be made in the calculator. So get a fraction going, get 5607.82 over 4,500, and then come out minus 1. And we've got 0.1. Oh, what did I forget to do? Sorry. Well, that's too big. I was thinking that's great interest. Jesus, I love that interest. We don't want this. We want, where is it? Yeah, shift this one, the fifth power, 0.045. So I is equal to 0.045. So what's that as a percent? Well, that's equal to 4.5% when you multiply it by 100. Okay, so that's that one. It's a very simple one. You're just manipulating things around. There's nothing too crazy, too complicated. It's not going to cause you trouble, keep you up at the night, that type of thing. Right, let me try another one. So, what have we got? The final value of 600 find the final value of 6,500 quid invested for 6 years and 4 months if the monthly rate is 1.932. Okay, so we're going on to monthly rate now. In fairness, that's an amazing monthly rate. So even I'd be impressed by that one. So let's list out what we have here. Okay, we've got a principal of 6,500. We want our final. We've got a time. Now, how are we going to deal with time? Well, listen, they've given me a monthly rate. So rather than try and make this a yearly thing, because that'd be awkward doing it as a year, let's make it all months. So how many time in months is going to be 6 times 12 plus 4, which is 76 months. And we've got an I, which is going to be let's break that down, 0.01932. So let's put them all in. The final amount is going to be equal to the principal bracket 1 plus I to the power of t. So final amount is going to be equal to 6,500 on 1 plus 0.01932 to the power of 76. So let's see what this ends up being. I'd love to have this. If somebody could offer me this in the morning, I could quit my job. So let's do this one then. So we've got 6,500 bracket 1 plus 0.01932 to the power of 76. So remember, this is compound and monthly, genie. Okay. So am I looking at this right? 27,000. Oh my God. Equals 27,830 euro and 10 cent. Now that's some serious compounding. Okay, that is some serious money. Okay, that's like crypto levels of stake in there going on. Right, so there you have it. We'll try another, and we'll kick it up a notch now. We'll try a little one that's a little bit harder. Okay. So, all right, let's have a look at this one then. Read it. I plan to borrow 175 grand. Fair enough. If the bank charges a 4.5%, what would this loan amount to if you don't make any repayment? So he's going to borrow it at 4.5% a year for 20 years. So it's going to compound yearly. So it's a bit of a weird mortgage. Just buy it now, or take the mortgage, take the money now. Every year you're charged 4.5% on that, and then in 20 years, how much would you have to repay? It's a bit of a weird one because that's not how mortgages work. But listen, we'll go with them. I know what they're trying to do here. Okay, so we have principal of 175,000. We have an interest of 4.5%, which is 0.045, and we have a time of 20 years, which I suppose, you know, it is what it is. It's 20 years. Okay, so final amount is equal to principal bracket 1 plus I to the power of t. So the final amount is equal to 175,000 on 1 plus 0.045 to the power of 20. So that's going to be a lot of money, the poor fella. 175,000 bracket 1 plus 0.045 to the power of 20. You're looking at final mortgage value of 422,049 and 95 cent, which is a lot of money. Okay, it's an exorbitant amount of money. Okay, Right, so let's twist this up a notch then. Have a read of this one here. Okay, using logs, find how many years it will take 1,000. Now they're giving you a hint. So we're looking for the interest. Sorry, we're looking for the years. So let's put in what we have. We've got principal, we have final, we have time. No, we don't have time, but we have interest 0.05. So let's put everything in we know. We know that 3,000 is gotten from 1130, 1 plus 0.05 to the power of t. Well, listen, if they're telling us to do logs, let's just use logs. So first step, let's divide across by 1130 to get rid of it from here. So that's 33,000 divided by 1130 is equal to 1.05 to the power of t. Let's get the log of both sides. So you see what we're doing here? We're just going to get the log of both sides. If we get the log of both sides, we should be okay, type of thing. Okay, so if I get the log of both sides, so the log of that, log to base 10 of 3,000 over 1130 is equal to the log of 1.05t. But there's a rule for logs that if you have a power, you can bring the power down in front. So that's really equal to t times the log of 1.05. And then I'm just going to divide both sides by that. So that's just the log of 3,000 over 1130 divided by the log of 1.05. That'll give me my t. So a fraction log fraction 3,000 over 1130 over the log 1.05. Oh, so out there, where have I made a mistake? Oh, didn't close off the bracket. 20. So 20 years. It's roughly 20. We're not going to round it up. It's 20 years. T is 20 years. Okay. Right. So there's the only manipulation I could see that might cause you a bit of trouble is we have to find the time. Okay. That's everything up until now you could classify as ordinary level or just very high end of ordinary level. This is definitely higher level. Okay. When you get into logs, you get into higher level. Right. We'll try one more. Okay. So if 6% interest is offered per year, calculate the effective monthly. Oh, okay. So we want to go back from yearly interest to monthly interest. Okay, so this is something that's slightly different. So I'm going to go through this with you and kind of explain it to you. You think to yourself, okay, well, listen, I'll divide it by 12. But if you look at the formula which we've been using, this bit of the formula, if this is 12, then this is made up of 12 equal, and I want to get down to monthly, then those monthly, if there's 12 of them going into 1 year, then it's this interest can't just be divided by 12 because it's being powered. It's not being multiplied by 12. It's being powered by 12 to get to that whatever final amount is. So what we really need to do is work out a way of figuring out a reverse power of 12 on that. So here's the easiest way to kind of think about it, okay? What's my yearly? Well, my yearly is 1 plus I, okay? And that's going to be equal to my monthly, which is 1 plus I to the power of 12. So those i's won't be the same, but yet they have to be the same thing, if that makes sense to you. So let's put in what we know. We know that this is 1 plus 0.06. Okay? And we know that this is just 1 plus whatever to the power of 12. So in order to get the I on its own, we're just going to depower this side, which means we're going to square root this side. And then that leave me with 1 plus I. And then to get I, we're just going to subtract from the 12th root of this. I'm going to take away 1. Just like before, I'm planning it before I do it. So let's see how we write here. Okay, so again, I'm going to use that button, the 12th root of 1.06, and then come out of that, take away 1. Right, that's 4.8 with 3 zeros, 1.00, so that is 0.004867, okay, which is basically multiply that by 100, 0.4868% to 4 decimal places. Okay, so when I multiply it by 100 to get a percent, that's what I'm left with. So that makes sense. So if I reverse the process now, okay, if I add 1 to that and then go to the power of 12, I should roughly get 6 or 1.6%. There you go. If I reverse the process, if I pop that in on this side, I actually get 1.06, which is pretty cool. When you think about it, it is pretty cool. Okay, right. So listen, thank you. See you in the next video.